You take a car, okay? I like running too, but every day to Brantford, maybe not. So, yeah, he tore his muscle pretty badly. Anyway, so you can see that there's a really interesting dynamic you can put on, you can add to your data there as well. So, putting it all together in terms of ultrasound. Now, here's a couple of guys in my lab. This is Dr. Peter Bevan right here, and he's just down beside, sitting beside Doug Barber. And one of my PhD students, Aravindan Jagathisan. So we're doing a lot of the development work on merging the modalities, and Peter's been very instrumental in getting all the ultrasound stuff going since he is an ultrasound expert. He's an ultrasound physicist. And so one of the things we've been doing is looking at the liver as a good example, a good starting place. So here's some work again, we're doing some work with Sentinel Medical. So this is fusing the data together. This is an MR, just a MIP. You can see all these little markers right here. This is liver on the MRI and liver on the ultrasound. Okay, so we're able to draw, we load up a 3D data set from MRI into our ultrasound registration system, and we're able to then use our transducer to guide ourselves through our high quality MRI data set. And then with the ultrasound, the physician then can put a biopsy needle or whatever they want in at that point in time and be able to visualize it on an MR image, a diffusion image, a metabolic PET CT, whatever they have in front of them. And we're working on a pedal system we can put on the floor to switch between these kinds of modalities. And there's Peter again. He's done some really, just some very interesting work on the brain because we thought, let's challenge ourselves. Ultrasound in the brain is really a nuisance. And people have done transcranial Doppler to look at blood vessels in the brain. Between the two of us, we couldn't have done this at all. But with just doing the co-registration with MRI, we were both able to see it like that, whoa, we feel like we're experts at doing this now. But it really makes life a lot easier when you're doing co-registration with ultrasound. Okay, I've got to say, new appreciation for that modality, without a doubt. Okay, to kind of summarize everything, and this is where we're going. Okay, we got multiple modalities we're putting together. We're getting multiple different kinds of function, metabolism, structure, etc. Okay, put it all together in one parcel for the physicians to actually use. But that doesn't mean we're done. Okay, if we're done, I'd be just taking it easy. But no, I'm not. There's a lot left to do. One of the big things is registration of real-time 4D changes, because a lot of times when you stick a biopsy needle in, the tissue deforms around the needle. So we have to be able to deal with that. And not just deal with it in terms of, okay, put it in, we've done it. The registration algorithms these days for 4-dimensional registration are taking on if you do it in MATLAB, it takes about 10 minutes. Forget it. Okay, that doesn't work. But if you do it in real time with like GPUs and things, it's getting down to about 3 seconds. So we got to get even better. So some of my colleagues in electrical engineering at McMaster are actually working with me on some ideas to improve on that. Co-registration between modalities can be a bit of an issue. The resolutions are potentially different. Maybe the slice acquisitions were slightly different, so there are some issues surrounding that. The computation speed requirements are astronomical. Again, we got to get into bigger and more complex computational systems, better design systems. So I'm working in computer engineering to try to improve on that as well. There's lots of growth there for that. And then the last point right here, there are lots of distortions with MRI. There's distortions and artifacts with every modality. It doesn't matter what imaging modality you have. If you have metal things in there and you have doing a CT, you get artifacts. Okay, there are some parts in a PET scan that will uptake the radioactive glucose, and that might be completely normal. So let's say they've got an infection, like they've got a cold. You'll see things happening that really they're not really a tumor, let's say. So that's the last thing we're trying to work on to really to correct our things. Okay, my time is up, and that's perfect timing. I always like to thank my lab, and here's a good picture of them just outside of our imaging center. All my students, and as I said, Dr. Peter Bevan is right here. He's back there beside me in the back row. And I couldn't have done all the work I do without all the great support I've had from all the funding agencies and some of my industrial collaborators as well. And thank you very much, and thanks again for the invitation, Dr. Anvari, for coming.